Hi. So it's funny. I think a lot of us have been here now around 7-ish years. I think Israel started just after I started. I think then he introduced me to Julie, who was 5 years. So, but roughly sort of in this time period. And when I first got to the Media Lab, one of the things that was the most confusing about academia was this sort of separation between staff and research. And I remember when I was first here, I ran into a neighbor. I guess I can be a little bit. This is sort of slightly off the record, right? So he ran into me and he said, "Oh, I'm a professor at Harvard and I won a Nobel Prize." He says, "What do you do?" And I said, "Well, I'm the director of the Media Lab." And he said, "Oh, so are you a professor?" And at the time, I wasn't a professor of practice. I said, "No, I'm just the lab director. I'm in charge." He goes, "Oh, you're on the administrative side of the house." And I was like, I didn't realize there were two sides of the house. And so one of the things when I got to the lab that I thought was very peculiar was the weird wall between the research stuff that was going on and then the applied stuff that was going on. There seemed to be, whether we were talking about cybersecurity or about facilities, lots of really cool demos. But then it's kind of like the cobbler's shoes thing, that a lot of this didn't seem to get deployed, and there seemed to be this weird wall. And so that was one of the first things I tried to do when I got to the Media Lab, but I found was one of the hardest things to do. And so after the last 5-7 years, I've been fixing the accounting system, fixing HR, fixing all the stuff that was relatively so-called low-hanging fruit. But I finally now have sort of finished fixing things, and I feel like this is a time to actually challenge what I think is the hardest but most important thing, which is kind of what you said, imagine, incubate, and impact, which is actually get our technology out into the real world. And one of the things that I did when I joined the Media Lab was there was a motto that actually was attributed often to Nicholas Negroponte, the founder, but it was actually, I think some students had written it on the wall when the book was written, which was the notion demo or die. That was sort of the Media Lab motto versus publish or perish. And that was sort of how we differentiated ourselves with the less applied parts of MIT. But I changed it to demo or die, not demo or die, deploy or die, because I wanted to get it out into the real world, because that was, to me, what was important. As an odd side note, when I got a chance to meet President Obama, he kind of was thinking deploy or die. And I think he was thinking deploy in a slightly different way. He said, maybe you should get rid of that die part. And I said, okay, all right. So I changed it to just deploy. But our mission now at the Media Lab is to deploy our work, not just demo it. And so with that, I want to dive in. I'm going to focus on a few different parts of what you talked about. But I want to start with, this is a friend, Lawrence Lessig. He's a Harvard professor. And in an older book, it's a 1999 book called Code and Other Laws of Cyberspace, he describes 4 quadrants: law, markets, architecture, which in this case he means technology, and norms. And he's a lawyer, so he put law on top. But somehow he says that these 4 things have to work in concert for things to change, right? So if you want to lower the speed that somebody's driving in your back street, you can either set up a speed bump, which would be a technical intervention, or you could change the speed limit and post a sign, which would be a legal intervention, or you could get the norms of society to try to get people to change, or you could create a financial incentive to drive slower. And whether we're talking about sustainability or we're talking about anything that we're trying to do, these 4 things work together. And as we think about sustainability and the environment, one thing that's really important to remember is that the environment is a complex adaptive system. So what does that mean? It means it's a system of systems where somebody's output is somebody else's input, and the Earth has a really good process because it's evolved over billions of years. So usually the output of something is the input of something else, and in a really interesting way, without a central controller. There's no thermostat for the Earth, but it stays roughly the same temperatures, same as our human bodies. And we have this adaptive part, which is interesting, because of all of the different interlinked systems. When you hit the Earth with something, or you hit an environment with something, or you hit our body with something, it tries to adapt, and it often does. And so weirdly, without a central planner or even a central designer, the complex systems that we've evolved have evolved to be resilient. So it's interesting. They don't need a campaign. We don't need a thermostat to control this fairly complex system. And interesting, a lot of work on complex systems originated here at MIT. So I wanted to talk a little bit about that. This is a picture from Donella Meadows' book. on systems, and she was a researcher here that worked with Jay Forrester and others. But just a very simple system is you've got the state of a system, you've got inflows and outflows, and then you've got somebody looking at it. So this is sort of like a thermostat. The state would be the temperature. You've got sort of air coming in, and then air going out, and then you've got your goal, which is the temperature you'd like to be, the discrepancy, and you sort of adjust both the outflows and the inflows. In the case of a thermostat, it's probably more the inflows. A better way that I like to think about it is like a bathtub. So in a bathtub, you're going to try to get in the bathtub, you're going to try to get to a certain level. You can turn the knob to get the water to come in. If it fills too high, you can open the drain, and then you sort of calculate what the right level would be. But in a bathtub, you're also probably doing temperature. So you're going to fiddle with two knobs, the hot water, the cold water. And then if you have an old house, the hot water knob's going to have a delay between when you turn it and when the hot water actually starts coming out. And then if you think about your system, well, the hot water is being powered by a power system, and the power system is connected to a utility. The utility is connected to your checking account, and your checking account is connected to your savings account. And all of these systems all have that same thing, which is inflows, outflows, and some level of regulatory control. But as you can imagine, just like it is when you have an old creaky house with a drain that's too small, it's pretty hard to get your bathtub just right. And the size of the tub matters. There's a bunch of things you can fiddle with in your bathtub to try to get it easier to control. So like a really sensitive knob with a tiny bathtub is really hard. A huge bathtub with a tiny drain is also really hard. And when you think about the size of the bathtub, in climate we would say it's like the carbon that we have in the air, right? So we can terminate our carbon emissions now, but the effect, because the drain is so small, of that carbon is going to continue for a while. And so thinking about systems, whether we're talking about HVAC or emissions, in terms of these interconnected networks of systems is a good way to think about it. And Donella Meadows, when she was here at MIT, did a lot of the early climate models, and she described how you might intervene in these systems. And I won't go through all of this, but it's sort of important to see, is she listed 12 ways that people can intervene in a complex system. And this is kind of complicated, it's sort of MIT nerdy. So it's an increasing order of effectiveness. So what she's saying is that the least effective but the most common intervention are things like constants such as subsidies, taxes, and standards. You could change the length of delay, like for instance, move the boiler close to the bathtub. You can change the structure of the information flows and all these things. But the bottom three, the goals of the system, the mindset or paradigm, and the power to transcend the paradigm, these are the least often used but the most effective. And let me describe those a little bit, because I think you mentioned behavior change in your slide. So the most important three principles, the others are important. It's important to change the rules. It's important to change lots of the systems. But the goals of the system, and then the mindset that produces the goals, and then the ability to transcend that mindset are, in her view, the most important. The example I'll use is Monopoly. So everybody knows the game Monopoly. What's interesting about Monopoly was it's based on a previous game called the Landlord's Game from 1904. And what the Landlord's Game was a game by the Georgists, who are kind of like precursors to the communists. And they created a game to teach kids the perils of capitalism and the fact that land ownership and rents would drive people to poverty. And it was a game that they would have kids play in order to learn how awful capitalism was. And what Parker Brothers did, which is really interesting, they didn't change the rules, actually. The rules are nearly the same. They just changed the goal to no, now you are the capitalist and you win if your friends become bankrupt. And so then the behavior changes, right, once you've changed the goal. So changing the goal without changing the rules was actually enough to change the game entirely. And the point being that it's not that the rules aren't important, but the rules aren't nearly as important as the goals, and the goals are derived by the paradigm in which we think. And so I don't mean to be anti-capitalist, but the somewhat irresponsible form of capitalism where you externalize cost and you win at every expense and you don't think about the system, those sorts of things, you could create all kinds of cap and trade and all kinds of rules and try to appeal to enlightened best interest, self-interest. But companies are going to figure out ways to optimize. And so as long as the goal is still to make as much money as possible at the expense of others, which is the goal for many people, and that goal comes from a short-term, return-oriented financial system. And if the consumer and if the workers and if the CEOs and the shareholders all believe that, you can create all kinds of rules for sustainability, but they're not going to work. I think the good news is I think people's values are changing. I think when you talk to students on campus, when you look at millennials going into companies, they're saying that they care about the social cause. And a lot of these things that are driving change aren't just a bunch of, it's important to have scientists, but just aren't a bunch of scientists doing math. It's actually society trying to change. And I think it's important to try to harness that part of it. This is one of my favorite pictures. So the Heart Attack Grill, this is in Las Vegas. The quadruple bypass burger is 8,000 calories. And there's a 30-minute wait to get in. And if you're 350 pounds, you eat for free. This is not an information problem, right? They know but they still go. And it's really, to me, my point is it's a mindset problem. So again, about the sustainability things, I think it's important to describe the impact, and it's important to have the facts and figures. But as long as people are kind of like, I'm going to have my car because it's fun to drive. I don't care if it's bad for pollution and it's not safe. And I think you need to get this mind change. So the behavior. This is another point on behavior change. I'll give an example of something from Japan. So Shinto is a 3,000-year-old Japanese indigenous religion. And there's a shrine called the Ise Shrine, which is about 2,000 years old. And from 1,300 years ago, what they always do is they're always building a second shrine every 20 years. And so what they do is they plant the trees, and every 20 years they cut down the trees in a big ceremonial ritual. And so this is part of the ritual. And they drag the trees through the town to remind everybody. And they actually plant another whole set of forests. So they have chunks of forest, hundreds of years old, throughout this whole forest, and the shrine is in the middle of the forest. And every 20 years, they rebuild this thing so that, one, they can teach the next generation how to rebuild the shrine, and to remind themselves that everything is renewable and that they live through integration of nature. And what's interesting about the Shinto thing is there's all these rules and all these rituals that have developed over thousands of years, all to try to remind ourselves that we need to live sustainably in nature. And the point here is that the rules didn't create the belief system. The belief system created a whole bunch of rules, which I'm actually trying to get the Japanese to care more about. There's a famous story. They put rocks across Japan, and they said, don't build below this. This was the high water mark for the big tsunami we had. And then everybody built, and it turns out that was actually where the last big tsunami came. So there's this really interesting thing about old cultures having long memories, and maybe some of it is about tapping into those. I wanted to give a couple of specific examples from the Media Lab. So we built a clean room recently. I'm going to skip the video here. It's a microelectronics microfabrication clean room. It's in the middle of, I think, our 4th floor. And what's interesting about it is the faculty member in charge is very obsessed with process and renewables and sustainability, and we're working with EHS on this. And so we have a very data-driven system that does everything from user metrics and equipment utilization, but also material consumption and forecasting. And we use a sort of based on Japanese manufacturing, a thing called the 5S lean efficiency system. And we've created this online, or she's created this online portal where you can get all of these operating procedures, but also a way to keep track of all of our equipment and all of our materials. And one of the things that we're hoping to do with this collaboration with EHS is to not just focus on the materials in her lab, but to start looking at all of, because it turns out we buy tons of toxic materials, we throw tons of toxic materials away, but the labs don't interconnect on reusing a lot of this stuff. And what we're trying to do is build something that we can test at the Media Lab, but then maybe standardize across MIT. And I think this is a great example, and hopefully we can work with Joe on doing something like this in facilities. I know Hildreth is working with food sustainability people. But the Media Lab, what we really like to do is try to experiment on ourselves, first of all, instead of trying to tell other people what to do. And if we can do it well ourselves, ourselves, hopefully that can get scaled across the institute. And so you know, the big thing that we're trying to do is collaboration. The data pool, I hope, will become a hub for us. I think the way that it's all open data and you have open interfaces is wonderful. So we're trying to figure out ways. We're meeting this morning about how can we add more sensors to collect more data? Can we maybe plug some of the control systems into here? And can we get students to write machine learning projects and other things to try to more efficiently create this loop, which is going back to the systems thing. Can we get the data, do the controls, and figure out ways to use the students' ingenuity on helping with sustainability? I think one of the biggest problems, and we had this as a part of the MIT IQ conversation, is that master students are here only for a brief period, and they spend about half their time getting their data sets and their experiments set up. But if we can have something where you have open data, you've got a bunch of APIs, and the students can just plug in and do their master's or PhD in machine learning, they can more efficiently do their academics, and we can more efficiently take advantage of that into something that could be used operationally. So we're trying to work together to set that up. So these are you'll hear more about this later. And I just wanted to end. I mean, this is supposed to be our motto. To me, research and deploy are really important. And I think we used to deploy through the government, through big companies. But now, with all of the technology that we have and the level to which our operating capability has become, I think deploying directly on ourselves is our big next step. And I hope to be your partner in that. Thank you. Should I take you? So I think I have a few minutes for if anybody has comments or questions or disagreements. Anything? Yeah. Okay. Well, look forward to working with you guys. Thank you.